Hi, in this video I want to talk about how you could calculate the inductance of a coaxial cable. Now, I've talked about coaxial cables 2 times before in class. The first to determine the capacitance of a coaxial cable, and the second to determine the resistance in a coaxial cable between the conductor in the inside and the outer conductor through the insulating sheath. Now, with capacitance increases with length. With resistance decreases with length. With inductance, it turns out to be a lot like capacitance. It's a property that depends on the length, and inductance and capacitance per length are 2 properties of coaxial cables that you'll need to pay careful attention to if you're dealing with particularly AC signals. Now, for inductance, the inductance of something like a coaxial cable that isn't made of many loops of wire is just the flux being produced by the coaxial cable divided by the current running through the cable. And to calculate the flux, we need to calculate the magnetic field. So to do that, we can use Ampere's law. If I were to look at some Amperian loop centered around the inner conductor, the magnetic field at distance r away from that central conductor would be equal to mu naught times the current in that conductor divided by 2 pi times the radius. So to figure out what the flux would be, I would need to take a look at determining an appropriate cross-section in order to calculate my flux. So what I'm going to do is imagine a length of my coaxial cable with a thin sort of slice of cable dr. And I would look at the magnetic field flowing through that thin slice dr along that entire length L. So my patch of area is going to be equal to dr times the length of my cable. So if I integrate my magnetic field, I can pull out all of my constants, so my flux would be equal to mu naught times my current times my length divided by 2 pi times the integral from the inner radius of the coaxial cable to the outer radius of the center of the coaxial cable from A to B. So when I integrate that, the integral of dr over r gives me the natural log, so my total flux would be mu naught times my current times my length times the natural log of the outer radius divided by the inner radius, all divided by 2 pi. And my inductance then is just going to be that divided by my current. Thanks for watching.